In this episode, we're looking at adding and subtracting fractions with unlike denominators. So in this lesson, we're going to rename two or more fractional numbers with unlike denominators to show the same denominator. We're going to add or subtract unlike fractions, including mixed numbers, without renaming, and solve problems that require operations on fractional numbers. Engage. Read the following poem. What type of fraction is it describing? Discuss your thoughts with a partner and ask your teacher for confirmation. Pizza rondo. Do not cut the pie if you are not serving one. You can eat the whole thing just for fun. Cut the pie in half if you are serving two. Everybody gets a half, me and you. Cut each piece in half if you are serving four. Everybody gets a quarter, but no more. Cut each piece in half if you are serving eight. Everybody gets an eighth. That's just great. Cut each piece in half if you serve 16. Everybody gets a 16th. That's too lean. Do not cut the pie if you serve 32. Time to buy another pie. Ain't that true? So, just from that alone, we can see that we have certain fractional numbers that are coming out here. For example, here we see whole, half, quarter, eighth, and 16th. Okay? Alright, and we have 32 here as well. They were dividing it into 32 pieces. To add and subtract fractions, we need to understand the relationship between fractions as described in the poem. Try learning it by heart. So it says, like fractions are fractions with the same denominator. Again, so like fractions are fractions with the same denominator. You can add and subtract like fractions easily. You simply add or subtract the numerators and write the sum over the common denominator. So here we have an example. Adding fractions with the same denominator, we have 1/5 plus 3/5. The tricky part comes when you add or subtract the fractions that have different denominators. Adding here, we have 1/5 plus 1/3. Before you add or subtract with different denominators, you must first find equivalent fractions with the same denominator. Examine the poster. So equivalent fraction here. Let's go. Equivalent fractions have the same value even though they may look different. They are fractions that name the same amount or part. So for example, we have a half, 2/4, 4/8 are all equivalent fractions. Okay, so I like to describe it this way. They have the same value but a different name. Same value, different name. Kind of like how we would call somebody a nickname. So we may say, come Pinky, but you're really calling Pat. Okay, same person, just using two different names. So let's look. A half is the same as 2/4, which is the same as 4/8. And here we have a little thing now. Equivalent fractions. A half, 2/4, 4/8, 1/5, 2/10, 3/15, 1/3, 2/6, 3/9. We can find common denominators like this. How do we find them? 1. Find the smallest multiple that is the LCM, the lowest common multiple of both numbers. Then rewrite the fraction as equivalent fractions with the LCM as the denominator. When working with fractions, the LCM is called the least common denominator, or LCD. Okay, here we have an example: 3/4 plus 1/6. Now we can't just add these and get 4/10. That would be incorrect. First, we need to find the LCM or the LCD and solve for equivalence, and then we are able to get our answer. Write the multiples of both denominators until you find a common multiple. The first method is to simply start writing all the multiples of both denominators, beginning with the numbers themselves. So the multiples of 4 are 4, 8, 12, 16, and so forth. And the multiples of 6 are 6, 12, and so on. That is the number we are looking for, 12, because it is the first one that appears in both lists of multiples, right? So it would be a common multiple, and in fact the lowest common multiple, right? It is the least common multiple, which we will use as our least common denominator. So we multiply the denominators of each fraction by a number that will give us a product of 12. It is important to note that whatever number we multiply the denominator by, the numerator must be multiplied by the same number. So let's look at this. We have 3/4 or 3/4 plus 1/6. Now I need to get 4 to become 12, so I'm going to multiply by 3. And if I multiply the denominator by 3, I need to multiply the numerator by 3. Okay, so this would be 3 times 3 and 4 times 3 plus, what do I need to do to 6 for it to become 12? I'll multiply by 2. And if I multiply the denominator by 2, I need to multiply the numerator by 2. So this first section here has to do with the 3/4, and the second part here has to do with the 1/6. So multiplied by 3/3 and 2/2, and now we end up with what? 3 3s, 9, and 4 3s, 12. That's the 3/4. So 3/4 and 9/12 are equivalent. They have the same value but just different names. All right, let's go to the second section now. We have 1 times 2, 2, and 6 times 2, 12. So the 1/6 now becomes 2/12. So 1/6 and 2/12 are equivalent fractions. Now we're just going to add the numerators now. So 9 and 2 would give us 11, and we are going to keep that common denominator. So our answer would be 11/12. Now 3, the same applies for subtraction. So the same set of rules. Once the denominators are unlike, we need to go through the same process of making them equivalent and then using the numerators to solve for addition, or in this case, as I said, subtraction. 4. A mixed number is a whole number and a fraction combined, such as 1 3/4. So we have 1 whole plus 3 out of 4 pieces. So what is 2 3/4 plus 3 1/2? You may find it easy to add the whole numbers first and then proceed with the common fractions as in the examples above. Or you may prefer this way, to add mixed fractions, convert them to improper fractions, then add them by finding the LCM, then convert back to mixed numbers. Okay, so let's look at this. Convert to improper fractions. 2 3/4 is the same as 11/4, or 11/4. Let's go with this. So we would say 4 the denominator multiplied by the whole number. 4 2s would be 8, and we add the numerator, so 8 and 3 would give us 11 over 4. Now 3 1/2, we would say 2 denominator times the whole number, 3 2s 6, and add the numerator, we get 7. Okay, so it would be 7 over 2, or 7 halves. What is the common denominator now? So we have 2 and we have 4. The common denominator is 4. So 11 over 4 stays 11 over 4, and 7 over 2 becomes 14 over 4. How? Because we would need to multiply 2 by 2 to make it the denominator 4 as well, right? So it can be equivalent to 11 over 4. So if we multiply the denominator by 2, we need to multiply the numerator by 2. And 7 times 2, that's how we get the 14. So 7 over 2 multiplied by 2 over 2 would give us 14 over 4. So by multiplying the top and bottom by 2, that's how we would get that. Now we're just going to add. So 11 over 4, 11 quarters plus 14 quarters would give us 25 over 4, or 25 quarters. Then we could convert back to mixed numbers now by seeing how many times 4 could go into 25, and it could go 6 whole times, because 6 4s would give us 24. 24 and the 1 would give us 25. So 25 over 4, or 25 quarters, is the same as 6 whole and a quarter, or 6 and a quarter. Okay. 6. The same method may be applied for the subtraction of mixed numbers. So now we're going to go to page 26 to see what they have to say. And it says here now, extend, play a game based adding and subtracting fraction at http://www.mathplay.com/adding and subtracting fractions game.html, and ask an adult to monitor you as you use the site. Why? Sometimes there are pop-ups that show explicit material, so you need to know what to do as a good digital citizen, all right, as you use the internet. So you can type into Google the search bar http://www.math-play.com/adding and subtracting fraction game.html. Okay. Evaluate. A. Calculate the following: a half plus 1, no, a half plus 3 quarters, 7/9 minus 2/3. And it says here, practice adding and subtracting mixed numbers at the website, and they have given us the link here. So mathgames.com, skills 5.73, subtract mixed numbers with unlike denominators. We can see here we have unlike denominators. So this website now could give you more practice with regards to the concept that we have done today. So in this episode, we were looking at adding and subtracting fractions with unlike denominators. And what's important? We must make them equivalent before we add or subtract. All right, guys, go to the website and complete those activities and share your results with your classmates in the comment section below. Take care. See you in the next episode.